All right, let's go ahead and talk about complementary and supplementary angles. This is Chapter 2, Lesson 2, page 81 in your textbooks. Let's go ahead and jump to the real world link here. It asks, what types of angles make up the two angles marked in the drawing of the bridge? All right, if we take a look at this bridge here, go ahead and erase some things. If we take a look at this bridge, we can see that there are two angles. And there's actually a little marking on these lines that kind of show us what the angle measure is. And it's the little square I just highlighted there. That tells us that we've got 90-degree angles. Those are also known as right angles. So let's put both there. So 90-degree or right for right angles. Number 2 asks, what is the sum of the two angles marked in the drawing of the bridge? Well, if we have 90 degrees on this side, 90 degrees on this side, the sum of 90 and 90 is 180 degrees. Remember that 180 degrees makes up a straight line or a straight angle. Number 3 asks, in the space below, draw a figure that contains two angles that have a sum of 90 degrees. And there are two ways you will see these drawn, typically on tests and in textbooks. The first way is when they actually draw and give you two different angles. We'll call this one 35 degrees, and we'll draw another angle. Go in a slightly different direction here. We'll call this one 55 degrees. And if we add those two together, we get 90. So this is an example of a drawing with two 90-degree angles. Another way we'll see this drawn is in one right angle. We have two angles kind of split up. So here we got 35 degrees and 55 here. Either way, we've got two angles showing that they add up to 90 in either drawing. But you'll see this in both ways in your textbooks and on tests. And here's a good picture example of one of those, page 82, talking about two very important vocabulary terms, complementary and supplementary angles. Complementary angles is when we basically have two angles that equal 90 degrees. When you add them together, their sum equals 90 degrees. And supplementary are going to be two angles that when you add the two together, you get a sum of 180 degrees. There's also something really important here is, in the paragraph below, the symbol, so you know what you're being asked or how to notate things when you're doing your math. This is how we say the measure of angle 1 here, measure of angle 3 plus the measure of angle 4 equals 180 degrees. It's kind of a short way to write these things. Instead of writing the words out, the measure of angle 3, we simply have a symbol to help us out and to make things quick for us. Just want to talk about also, before we move on, an easy way to remember complementary and supplementary in terms of not getting them confused. Let's think about the alphabet. C comes before S, just like 90 comes before 180. It's just an easy way to not get those confused, because on multiple choice tests, you'll be presented with answer choices, both complementary and supplementary, and you don't want to get the vocabulary mixed up. All right, let's actually take a look and move on here to a couple problems at the bottom of page 82. We want to determine whether these are complementary, meaning they add up to 90 degrees. They're supplementary, meaning that the two angles add up to 180 degrees, or that if they might be neither. So with letter A, I can see that 85 degrees is the measure of one of my angles, and 90 degrees is the measure of another one of my angles. When I add these together, they give me 175 degrees. Now, since that's neither 90 nor 180, these two angles don't represent a complementary or supplementary relationship, and they're neither. Now, with letter B, 75 degrees plus 15 degrees does in fact equal 90 degrees. So here I do have a relationship. I have a complementary relationship. So these angles are complementary, meaning that when we add them together, their sum equals 90 degrees. All right, now on to the algebraic part of this section. Okay, page 83. You can use angle relationships to find missing measures. And what we're going to do is we're going to find the measure of each one of these angles, measure of angle x, using what we have here. We don't need anything else. We're going to figure out what the measure of each of these angles is. We're going to do that by first thinking about what complementary and supplementary angles mean. We do know that we have a straight angle here, and that whole thing must equal 180 degrees. We also know that within that 180 degree straight angle, we have a 90 degree angle here. So what I'm trying to figure out here is the measure of this side, the left side of this drawing. Now I know that the total has to be 90 degrees over here because 90 plus 90 is going to give us this measure of this straight angle. So whatever x is, I know I need to add those together to make 90. What I can do is take my two x's and put them together to make two x's and then solve. Now remember, when solving an equation like this, we simply want to get x isolated. We want to get x all by itself. And we do that by working the problem backwards. We think about, what operation is actually going on with the variable. Here it's multiplication. And we want to think about, okay, well, how do I undo that multiplication? And of course, the opposite of multiplication is to divide. And we divide both sides by the same number, 2. 2 divided by 2 gives us 1x, and that's exactly what I want. I want to know what one of these x's equal. 90 divided by 2 is 45. So just one of these x's equal 45 degrees. And that makes sense because now if I add 45 and 45 here, I know that that will give me 90. That these two numbers plus my third number 90 here will equal 180 degrees, which is the measure of this entire straight line or straight angle down here. Okay. All right, let's move on. Now let's go ahead and take this and actually solve a problem with it. What is the measure of the angle given by the opening of the scissors? Here we've got a straight, oops, let me start that over here. A straight line, a straight angle. And we've got two angles making it up. Try to make that just a little bit better there. So we've got two angles. We've got 116 and 8x. All right. And if you visually look at this straight line, these are supplementary angles. They're going to add up to make a straight line, 180 degree angle, straight angle. So if I take 116 and add it to the expression 8x, even though we don't know what x is yet, we do know that they're supplementary angles and that they add up to 180 degrees. And now we're simply going to solve this equation to figure out what x is. We're going to start by eliminating any addition or subtraction first. We want to get rid of this 116, this number that's out here by itself first, by subtracting it. Thinking about, how do I just make that number disappear? The only way is to take away 116. I have to make sure that I do that from both sides here. That's one reason why I draw this line in the middle of the problem, is to remind myself to take away the same thing from both sides. So here we eliminate 116 because when we take away 116 from it, it becomes 0. We're going to drop down our 8x's because we still have 8 of those to break apart. And then here we've got 180 minus 116. Go ahead and do that real quick. And you should end up with 64. Now it's looking a little easier, or it should be. Now we're just going to break down 8x's so we can just figure out what just one of them is. We're going to divide by 8. It's going to eliminate that number. And then 64 divided by 8 gives us 8. So x is in fact 8. So when we think about what the measure of the angle is given by the expression, it's not 8, it's 8 times x. This is the expression. But since we now know what x is, we know that x is now 8, we're simply going to take 8 and multiply it by x. And 8 times 8 gives us 64. So the missing angle is 64 degrees. Don't forget, we can check that because we know these are supplementary angles, and then if we add them together, they should give us 180. And sure enough, they do. Let's go ahead and take a look at some of the guided practice, and we'll work on some more of the algebra part on page 84. Number 1, if I add together 135 and 45, I do end up with 180 degrees. That makes these supplementary angles. Number 2, if I add together 67 and 23, we get 90. That makes these complementary angles. Now with number 3, we want to find the value of x. We're not really being asked to find the measure of the angle like we were in the previous example. This time we just want to know what x equals. Now remember, just like the last problem, we've got a straight angle that equals 180 degrees, and we've got 2 supplementary angles that make up that angle. 3x is the expression for one of those angles, and 45 is the given measure of the other. And we know that together, when we add those together, we know that they're going to equal 180 degrees because they both make up this same straight angle. Now we're going to solve this algebraically. I'm going to draw the line down the middle of the equation. And feel free to rewind over this if you need to. Again, remember, we're going to take away any addition or subtraction away from the x. We're going to take away 45 first. 45 minus 45 allows us to eliminate that, and now we only have 3 x's left. So at the end, we're just going to have to break those x's apart. 180 minus 45 is going to give us 135. Okay, now all we have to do is divide 135 by 3 to get our final answer. And x is going to give us 45. Like I said, if you need to rewind that, please feel free to do so. Algebra equations are something we'll be working on all year. It's something you worked on a little bit last year, but we have to get really good at those this year. All right, and I think with this problem, I do want you to go ahead with number 4 and get these very important notes down. All right, I do have them right here for you. It asks, how are vertical, adjacent, complementary, and supplementary angles related? And you can probably write a huge paper on this, probably not right now, but once we learn the stuff, we're going to keep it short and sweet. Let's go ahead and get this sample answer down, just so that you see what a good example of an answer looks like. So adjacent angles are 2 angles that share a common side and vertex. Vertical angles will never be adjacent. Remember, they are straight across from each other. Complementary and supplementary angles may or may not be adjacent. So they don't have to necessarily be next to each other to be supplementary or complementary. I showed you with the one drawing that sometimes you'll just get 2 angles thrown out, and you're supposed to add them together to determine whether they're complementary or supplementary. They don't necessarily have to be touching each other. And sorry, I'm going to go back, but don't forget, you're definitely going to need to pause on this to allow yourself to catch up and get the notes down. We're going to go ahead and move on. Okay, I would like you to try some of this independent practice, but I do want to go ahead and actually move on to looking at the worksheet, the Lesson 2 Skills Practice worksheet. So here we're going to pause the video. We're going to allow you to work on some of these problems, and then when we're done, we'll come back and we'll take a look at working some of these out.